Hi, this is Dr. Sanjaya. Personalised medicine is a new approach to healthcare, looking at a patient's genetic profile to help prevent, diagnose and treat disease. My latest guest on Behind the Curtain, Dr. Simon Jiang, is leading in this groundbreaking work right here in Canberra. Let's jump into our chat. Welcome to our Behind the Curtain podcast, where we've found another extraordinary personality who works at Canberra Health Services. Today we have Dr. Simon Jiang, who is a senior staff specialist at Canberra Hospital as a renal physician and also an associate professor of medicine at the ANU. Welcome, Simon.
Thanks, Sanjay.
And what are you up to at the moment? Are you doing clinical work at the moment, or...?
So currently I split my time between clinical work as a nephrologist at Canberra Hospital and then also running a research laboratory over at the John Curtin School of Medical Research at the ANU. So I kind of do a full on-call for nephrology and then I also do my kind of outpatient clinic work in renal.
And Simon, for those listeners out there who don't know much about autoimmune disease, they've heard about it. Do you want to explain that a bit, please?
Yeah, so autoimmune diseases, so our immune systems are designed to have the ability to recognise bacteria and viruses, those things that are constantly trying to infect us. But at the same time, it has to have the ability to discriminate between what's invading organism and then what's self-tissue. So when the immune system loses the ability to distinguish between those two things, it can start to attack the body, and then that in itself can start to cause a kind of a chronic, damaging illness.
When did you realise that you want to do research? Because I can tell you, a lot of us clinicians, we are interested in research in terms of consuming it, using it to guide our practice, reading about it. To some extent, doing hospital-based research, so clinical epidemiology, looking through hospital records of patients to find associations between diseases and certain risk factors and outcomes, etc. But going to a lab and doing research, and mixing that with medicine, that's something altogether. What was it? When were you drawn into that?
I think my tipping point, again, related, was actually in my intern and resident year in terms of wanting to go and do more or understand more. And again, it comes back to these immune mediated diseases. So we had a few people that I looked after who had quite severe autoimmune diseases. And I just remember while I was on the term, we struggled for weeks and weeks to even make a diagnosis.
And Simon, there was one particular woman in her 40s?
Yeah, she's the one that always stands out in my mind. So she had from childhood kind of quite a significant autoimmune disease, and when she came in as a result of treatment and some side effects from the disease, she'd had a kidney transplant and some hip replacements, and she came in and she was just very unwell, and we spent a long time trying to figure out why she was unwell.
And let me just say, 40 years old, you've already had a renal transplant, you've already had hip replacements. Yeah. That's crazy, isn't it?
So it's already, and that speaks to how, the debilitating nature of these autoimmune diseases, that they tend to be they come and they go, but they tend, even when they go, they leave behind a bit of damage. And so that was something, so she was already very sick, and we tried our best, really tried extremely hard, and despite best efforts, she just got sicker and sicker, and so it actually ended up being that she passed away. And right. I think that I was quite young at the time, and it left a very kind of indelible mark for me that we don't understand these conditions well, and our lack of understanding of these conditions means that that people don't do as well.
So this particular woman, did she have a clinical diagnosis, or it was autoimmune disease of unknown origin?
It was what we would call a mixed connective tissue disease, which right. You would say is like a kind of a throw it all in one basket, where it's got a bit of this and a bit of that. Looks a little bit like one and a little bit like something else, but it's not really quite clear. And that happens an awful lot in autoimmune diseases.
Okay. And so, again, this wasn't as a registrar, a fairly senior doctor. This was as an intern. You saw this and you decided there must be a better way of doing this.
Yeah, I kind of vaguely remember the thing in my mind was surely this can't be the best that we can do. That we run at the time was kind of doing some CT, an MRI, a CT scan which didn't work very well because of the hip replacements. Some blood tests, physical examination, we did a white cell scan and things like that. So trying to do a couple of tests, and really the best that we could do really didn't kind of make it past, to me at the time, felt like a very superficial level. And then the fact that she didn't do well just left me this thought that we must be able to do better than this.
How did that seed that was planted grow over the next couple of years into research?
So I did my basic physician training in Canberra. When I passed the exams, then I started to do a lot more research. And I was really at that phase where I knew I wanted to do research, but I was just trying to figure out that what is the, as you're saying, clinical, or is it clinical trials or cohort studies, or is it basic science? And there wasn't really a lot of basic science that I was exposed to in Canberra at the time. But I obviously had a very strong interest in immune diseases by that point. And I was just kind of trying to figure out what is going to be the best, what would be the thing that I enjoy the most that allow me to, improve our understanding, research these immune diseases. And so I went and did a transplant year at Royal Prince Alfred in Sydney.
They had a TV show, didn't they?
They had a TV show, yeah. So, so I remember actually, at 2 a.m. in the morning, I was doing a kidney transplant. Someone who just had a kidney transplant, and I spent an hour doing all the work and the workup. And then the surgeon came in. They told me to go over behind the desk. The surgeon came, talk for 5 minutes with the cameras, and then disappeared. And then I had to stay for another hour to kind of help stabilise the patient and things like that. So I was like, it was a good experience in media. But I had actually thought when I went there that I would get exposure because they had University of Sydney on campus and other kind of big institutes that I get a lot of exposure to fundamental basic science research. And there was a little bit, but not really, and nothing in the autoimmune space. And so in that instance, I came back because at the ANU and at the John Curtin, there was a couple of very prominent basic scientists working in immune diseases, and I kind of realised that would be the skill, that would give me the skills that I need.
Would you say advanced scientists working in basic science?
Oh yes, they were kind of they're the very eminent they're kind of what we call it translational science or fundamental science, rather than clinical science, which is the randomised controlled trials and cohort science. Yeah.
And actually, just before we head down, continue with your journey, we hear about translational science, translational medicine. Can you explain what that is?
What we're talking about is trying to identify fundamental insights into different things, whether it's cell biology or genetics or RNA. So something on a very what we call, say, basic or fundamental science level.
Yes.
But then taking that and bringing it into the clinic and using that in a way that has clinical impact, improves diagnosis of patients or improves their treatment.
Yeah, so translating a discovery from the lab to the bedside, because otherwise we know that we see these wonderful studies done in mouse model, mice models, etc., where a drug or some intervention looks extremely promising for a debilitating disease, but it doesn't get to the bedside for 20 years or so.
Yeah, exactly.
So translational medicine is about trying to get it there more quickly, is it?
Yeah, exactly. And so a lot of what we do, which is one of the big things that we deal with, is trying to go from the clinic to the laboratory and make fundamental discoveries, but bring that back to the patients in a way that's clinically meaningful for the patient, like in a time frame that's meaningful for the patients, because there's no point figuring out and discovering what's going on and how to treat it and things like that, and then the person's passed away because you've kind of
Exactly.
What's the point? Yeah.
Exactly. So you, as you said, you found these amazing scientists at John Curtin.
Yep.
And so then what happens? I'm a clinician. I'm going to be a renal physician, but I'm really interested in research. Can you give me a table in that lab over there, or how does it work?
Well, pretty much. It pretty much was that. So I reached out to named Carola Vinuesa. So she published kind of very seminal works in immune biology and autoimmunity.
Yeah.
I said, look, I've got no lab experience. I've never held a pipette before, but I'm quite interested in basic science research in immunology.
I've dropped a pipette before, I should
Yes. Yeah. I think I was holding mine upside down the first day I was there, and everyone was shaking their head.
Yes.
So I reached out and I said, look, I'm interested, and I think Carola actually started by saying, why? She's like, why would you leave the clinic? You're fully trained, you can go start a job as a consultant. Why would you come back and do this? And at the time, my thought was just, I want to learn how to do it. I'm not quite sure where it lives, but I want to learn how people make fundamental discoveries. Not really sure where it's going to go, but I want to learn that skill set. So it was kind of like a big reset. I kind of went back to being a medical student. I finished all my training. When you went back in the lab, I had no skill set. People talked in a language that I didn't really understand, the scientific jargon.
Yep.
And I just had to kind of go in and learn it.
So your early days in research in the lab, what sort of things were you working on? Was it different to what you're working on now?
Yeah, it was. The first 12 months of my PhD, I was working on two very healthy mice. So at the time, I think my supervisor was saying, I think these mice are going to have something wrong with them. We're not really sure. And I spent 12 months doing a lot of work on these mice, and they were profoundly healthy. So at the end of my first year...
Very selfish of them.
That's what I know. That's what we're here for. No, so at the end of the first 12 months, I just said, look, I don't think there's going to be a PhD coming out of this, because these mice are, no matter what I do, they seem very, very... Maybe we can study them as exceptionally healthy mice. And so in my second year, but I did pick up a lot of skills in terms of learning, lab, the basic science and things like that. In my second year, I said, we probably need to change my project. And so we were actually then it kind of started to move closer to what I do now. And we were some of the first patients with autoimmune disease, lupus in this case, who underwent whole exome sequencing. And we were kind of the first to try and identify genetic variants that were causing immune disease in humans. And so that ended up being my PhD studies in terms of proving that genetic variation was causing what we call sporadic autoimmune disease, and more just not familial autoimmune disease.
No, and it's built up from there now, and I think you call it personal medicine, isn't it?
Personalised medicine.
Personalised medicine.
Yep.
Yeah. So you target the patient, the specific patient.
Yes. So the research kind of, I guess, and that's the thing is where we are now is probably 12 or 13 years of not just the research but development of the approach to understanding. So it's not just genetics. We don't just use whole genome sequencing, but we had to kind of build special bioinformatic pipelines to handle next generation sequencing and all these other specialized ways to analyze the white blood cells of patients, measure their cytokines and things like that. So it evolved to that point. So probably in the first 5 or 6 years, it was really just, can we even show that genetic variants in patients with immune disease cause autoimmunity? And so that was the first couple of years was just knowing that we could do that. And then we had a couple of very big discoveries showing that, yes, actually you can. And I think my big thing was saying that if we coming all the way back to the patients that I looked after when I was an intern that kind of left that mark on me, I had now developed a skill set where I could understand immune disease at kind of the genetic and the cellular and the RNA level. And the question, what we hadn't really done is, why can't we then use that information to help them, to treat patients? And so the last kind of 5 years has been, in my lab, a very strong push not to kind of accelerate it, both understanding it, the basis of autoimmune disease, but using that translationally to actually change what we're doing in the clinic.
Yeah, so rapid technological advances in the lab, but bringing it to the bedside as soon as possible to help people.
Yep.
which is great. Has there been a eureka moment that so far, I think you've got an exciting career ahead of you the next few decades, but so far, has there been a eureka moment where you go, oh my God, this is it. I understand now. This is going to be great.
There's been a lot of them actually, and that's the one thing. It was hard yards to in terms of to get that training, the skill set. But now I can never go back because it's kind of almost every week we're having this is something completely new, and when we say new, it's a gene in which we didn't know a function of, or a biological process or something like that, which no one else hasn't been discovered. And so it's a constant discovery in the lab. It's really exciting. So I would say at the moment, kind of the headlining things that are kind of in a big level the most exciting. So we had one individual, and we're kind of fingers crossed. We're in kind of a very top tier journal, trying to rebut it to get submitted. But we've actually essentially identified a new cause of autoimmune disease. And we did create a mouse, and we're actually able to show that the mouse developed all these abnormalities in the immune system, and to treat the mouse.
And look, just research jargon, you created a mouse. Do you want to?
And we first start by trying to understand, identify genes, and have some preliminary data that the mutation is doing something. If we really want to get into it and start to try and figure out a treatment for them, we end up creating essentially a mouse avatar. So if they've got a particular gene mutation which we think is driving the disease, we use CRISPR editing to create a mouse carrying that mutation so that we can then go and study it in depth and its response to treatment. Okay. So this is an individual who's been in Canberra, for 15, 20 years, had a really severe immune disease for that period of time, and had gone through a number of immunologists and rheumatologists. He became known to me because he had a kind of very low blood phosphate, so my renal hat.
Yeah.
We brought him into the personalised medicine program and found a variant genetic variant which hadn't been found elsewhere. And we're basically able to show that it was causing his immune system to become hyperactive, created a mouse which replicated what he had, and we're able to, with that insight, treat the mouse. And the mouse we dampened down the hyperactive immunity, and we gave him the tablet, and then his disease went into kind of complete remission. And then we actually found there was probably another 8 or 9 people in Canberra alone who had a similar mutation in the same gene, who had autoimmune diseases, and several of them have now started the same treatment. So essentially what we're able to do is find kind of a complex disease which wasn't diagnosed. Find the genetic basis and how to treat it.
There are 2 aspects that I'd just like to talk about. So first is the identification of the abnormal gene, which you've done. But now you've identified it, then you talked about treatment. How do you treat? Now, for example, I know with sickle cell disease in the US, they've used CRISPR editing to actually create a couple of medications that can target sickle cell disease and potentially cure it at a genetic level. So is that what you're talking about here?
No, because we're not treating it at the genetic level, because I think the ethical and the legislative frameworks for that are not really evolved, are not established to deal with CRISPR editing of, we would need to be editing germline. Basically bone marrow editing and doing an autograft or something like that. And so there's no framework for that kind of, no agreement on that. So ours is actually, again, the principle is if we understand it better, surely we can treat it better. So when I say that we identified the gene, we did a lot of work showing exactly what the mutation does to the immune signaling within these thing called T cells.
Yeah.
So we're able to identify a thing called NFAT, nuclear factor of activated T cells, and it was supercharged inside anyone who carried this mutation. And there's a drug which we use all the time in kidney transplant and other diseases, tacrolimus, which targets NFAT directly. And so we're able to use a cheap as chips on-the-shelf drug to target just because we understood what was going on better.
Okay, wonderful. And I mean, tacrolimus, I mean, like all medications, does have side effects, but at the same time, you're not using it in combination with other immunosuppressants, so it reduces the side effect, the pill burden, everything.
Yeah, so I mean, for him, his outcome was pretty phenomenal because he's wheelchair bound because of he couldn't get below 15 or 20 milligrams of steroid, and he's wasting phosphate, so he had a lot of fractures and things. Fractures. He's as a wheelchair bound.
Yeah.
When we were able to get him onto the tacrolimus, he's down to kind of 4 or 5 milligrams of prednisone. Now he's up and walking, no fractures and things like that.
Yeah.
Actually did break his collarbone because he climbed on his roof and was emptying out the gutters and things like that. So, the burden of the illness and the burden of his treatments have kind of dropped off. I mean, when he came to me, he was taking about 60 tablets to replace his phosphate per day, and the pill burden alone is crazy. So with the tacrolimus, all of that phosphate requirement went away. So he's gone from like 64 down to 0. Yeah.
So basically, you've improved his quality of life enormously.
Oh yeah. It was and that was exciting.
Yeah.
Very exciting. Because the other big eureka one is kind of the flip. We again used CRISPR to create a mouse. So we found a gene which we thought increases or mutation increasing the risk of immune disease. And actually, what we found, and we've kind of since understood it though. At the time, I thought it might make other mice with immune diseases get worse. But when I bred the mice together, it basically stopped any mouse from developing kidney disease. So autoimmune kidney disease, the presence of this mutation just seems to kind of switch it off. So we're actually in this process now of creating a drug, first-in-class drug, hoping that we'll be able to use it to prevent autoimmune kidney disease because no matter what we throw at this mouse, we can't seem to induce autoimmune kidney disease.
So just in practical, at a clinical level, that means someone with, say, a condition like lupus, where they're prone to kidney disease or other forms of vasculitis, ANCA-positive vasculitis, and you know that there's a high likelihood their kidneys will get involved. You're saying giving this drug hopefully will prevent that.
Or even if they develop it, to treat it. Yeah. So again, and this is kind of the weird and wonderful, and this is why I find the translational, the discovery science, so exciting, is that we, even when you think you might have a suspicion, you know what's going on, things just pop up and they're kind of in something exciting and new.
So these unexpected tangents you're travelling.
And I think there's that famous saying, which is actually that most discoveries, major discoveries in the lab, don't start with eureka. They start with, this comment, oh, that's strange. And that's actually probably true. You kind of look at things and go, that's strange. And then it goes completely against what you think is going on and opens up, a whole new dimension.
And Simon, you also mentioned kidney disease and your research with personalised medicine. I believe that's taken you to the Tiwi Islands with Indigenous people. Is that right?
That's right.
How did you get there? It's a long way from Canberra to the Tiwi Islands.
It is. So I suppose it comes down to, so the Tiwi Islands are reported to have the highest rates of kidney disease in the world. So they kind of, for an island of 2,500 or 3,000 people, I think they've got 2 dialysis units.
Wow.
It's the leading cause of death, and I think that, I can't remember what the number is, I think it's something about 20 to 30% will have evidence of kidney disease by the age of 30, or something like that. So huge rates of kidney disease. And they seem not to exist, these rates, kind of epidemics of kidney disease didn't exist 30 or 40 years ago. So there's a whole raft of community elders who have no kidney disease. And at some point, the incidence just suddenly ramped up.
Wow.
So they did some researchers through Tasmania, now the ANU, and the Menzies in the Northern Territory went in and asked this question, is there a genetic element to it? And so they, working with the Tiwi Land Council, agreed that they would do genetic studies, and it was whole genome sequencing at the time. And essentially what they were able to show was that there was a very large, maybe they estimated that kidney disease, maybe about 60% of that was heritable, in terms of there was a familial or a genetic component. 60% of the risk of kidney disease in the islands was going to be hereditary.
But it wasn't in the elders, though.
That's right. So which I'll come to.
Okay.
So they were kind of searching for quite some time, and then I think it's maybe about 5 years ago, one of the researchers at the ANU came to me and said, our personalised medicine approach, where we'd had successes identifying lots of different variants and showing how they cause disease, and then I was a nephrologist, would I be interested in working with them to try and get to the bottom of what could be, what could be the cause of kidney disease? And so we've maybe in the last 3-4 years, we've been working quite hard, intensively on trying to understand what could be the genetic basis of kidney disease on the Tiwi Islands.
Yep.
And actually, so some collaborators of mine published in Nature at the start of this year that the genetic diversity in Indigenous communities across Australia, from East Coast to West Coast, there's kind of the same genetic diversity as between Asia and Europe. So
Okay.
there's huge diversity. But what we're actually able to show is that there are quite a number of gene variants in the Tiwi that are having very profound impacts on the immune system. And we created another mouse. And so we have a mouse that's actually developing kidney disease based on, all the mice are developing really profound kidney disease by about 20 weeks of age for the mice. So, yeah.
Okay. So potentially you see a treatment that might come.
Yeah. So sorry. So coming back to your, why there are healthy elders and now the.
Yeah.
So these are genes, and the variants are all important in controlling inflammation. And so our kind of working idea at the moment is actually there's something kind of similar to sickle cell or something where there was some kind of environmental pressure where increased inflammation, increased inflammatory responses were protective or beneficial. And then when you change that environment, so it's a Western environment, there are different pathogens that have been imported from Europe, what was previously protective then maybe starts to be less desirable or starting to cause more inflammation, damaging the kidneys and the heart and things like that. Mm-hmm. And the good thing is that this pathway is through something called TNF, and there is an anti-TNF meds on the table, already on the shelf. So again, we're at that stage if we can show that blocking TNF is going to help prevent that kidney disease in the mice, then there is potentially a therapeutic option. And no one treats kidney disease with anti-TNF, anyway, really.
Are you is this very novel research in terms of your lab, or is this something that other people were doing for a little while in Australia or around the world?
I guess it depends which.
Or some aspects of it.
So I think there are aspects of it happening in Australia and around the world. So there's people who've been working on what we call immunogenomics, so the genetics of immune disease, both immune deficiency and autoimmunity. That's been happening in bits and pieces around the world. And people have been trying to understand autoimmunity using different, not just genetics, but different things like, as I said, flow cytometry, analysis of the white cells, and analysing the RNA of the immune cells and things like that. And so people have been trying to use particular technologies to understand the fundamental cause of immune disease. I'd say, during my PhD, we were probably the first to be trying to, I would say, do personalised diagnosis or personalised understanding of the mechanism, probably one of the first in the world. Yeah. In terms of bringing it full circle and actually trying to intervene and use it translationally, and that being a key focus, I'm not sure, I'm not aware of anywhere else in the world who's actually trying to do that.
Yeah, so fantastic. So, and even if you are novel, I think people will be inspired by what you're doing and hopefully start doing it elsewhere.
Yeah, well, so we do have collaborators around the world. So we were working for some time with the Renji Hospital in Shanghai.
Yep.
We get referrals, people from the US, from Europe, and currently kind of working with setting things up also in Sri Lanka.
Yeah.
So it is this type of thing where when we've had in addition to that patients talking about other patients who have had very good outcomes, and so clinicians are starting to refer more, not within Australia but outside as well.
Do you see any advantages to being a clinician researcher in Canberra compared to other places? And would you certainly recommend someone who's thinking about doing this hybrid career that you've taken on, would you recommend Canberra?
I have been offered positions to go to, Melbourne, to Royal Melbourne and Weehai, Westmead. I was offered a job in Royal Prince Alfred, and said no. And so Royal Prince Alfred, I said no and moved down here to come back to the hospital and also to do the research. I've turned down taking positions at these kind of other institutes.
Yeah.
And it's a combination of things. I think Canberra's a wonderful city. It's got, for me anyway, everything that I want. There's lots of space. The people are kind of super friendly, lots of amenities. When I came here, I have to say dining and stuff wasn't great, but now it's kind of I would actually argue it's a foodie's dream these days.
I agree.
When it comes to facilities, one of my big things was that I wanted to do a whole raft of different things. There's world-class facilities at the university, ANU, to do the research that I do. And then I think there's also an appetite to be able to do new and exciting things in the health service. And there's a lot of excellent colleagues and things who you can work very easily with. So I think it's kind of, for me, it's kind of the perfect melting pot to be able to collaborate broadly with clinicians. It's got very, the hospital has good facilities, the university has good facilities, and the surrounds are just, have an excellent lifestyle.
It's all close by.
Yeah, well, everything's 15 minutes from me.
Wonderful. Simon Jiang, thank you for coming on Behind the Curtain.
Yeah, my pleasure. Thanks for having me.
Thank you for listening. I hope you'll join us behind the curtain for our next episode, where we'll delve into the story of another of our fantastic health professionals here at Canberra Health Services. If you're interested in starting an exciting career with us, head to our website to join Team CHS. And that website is www.canberrahealthservices.act.gov.au/careers, CAREERS. I acknowledge the Ngunnawal people as traditional custodians of the ACT, the land I'm recording on, and recognise any other people or families with connection to the lands of the ACT and region.